If your program is taking too long to finish, it might be a good time for you to look into concurrency. Now, I know like concurrency can be a nightmare in other languages. You gotta install a whole bunch of libraries, you get stuck in a loop and nothing goes right and you hate life. Like coming from the world of Python and JavaScript and just doing single-threaded languages for my entire life, it was just so hard to get into multi-threading. But just Golang really makes it a lot more simpler to think about concurrency in a very intuitive way. And today in this video, I'm going to show you a real-world example of a program that runs 6 times faster with just some basic concurrency. Now let's set some context before we actually get into the code. So what I want is I have an API, and this API has a couple things in it. First of all, I want 1,000,000 rows of data from this API. So what does this API do? This API allows me to set 2 parameters called offset and limit to sort of like specify, okay, how many rows do I want? So let's just run into these real quick. Limit is pretty obvious, like how many rows do you want? 100, 200, etc. And offset is how many rows do I want to skip? So this is how I want to work with this API. Now you can imagine, like if my limit is set to 100, I gotta send 10,000 requests to get 1,000,000 rows at the end. So you can see like this gets pretty slow pretty fast. If I want 2,000,000 rows, I need to send twice as much requests. And really just thinking about it, let's just sort of like run into the basic sort of building block of what we want here. So I'm just gonna make a new package and main, and so I'm just gonna make a function main, and first of all I'm just gonna have my .env file ready, so go.env.load just to get my credentials right, and if this did result in an error, I'm just gonna format printf error %v\n error. Okay, nice. So now we can get into the actual meat of this. This main loop is going to stick with us till the end. So I know that my limit, I'm just going to set it to 100. So I'm going to like need 100 rows per request that I'm making. And I'm going to set the entire sort of like rows into 1,000,000. In total, I want 1,000,000 rows. So when you think about it, it's like, okay, it's a for loop, right? So like you range over an array of integers with a length of rows, a length of 1,000,000. So what I have here is I have a API package, and this API has a sort of a function called getData. And what this getData does is that it takes an offset and it takes a limit and returns back a pointer to an array of API data. Exactly what I wanted. Every time that I set the limit to 100, it's going to get me an array of 100 items in it. So if you think about it, like first my offset is going to be 0. Then my offset is going to be 100. Then it's going to be 200. So how it's going to work is my offset is actually I times the limit, right? It's pretty obvious. So I'm going to have my offset here, and I'm going to pass in my limit into this. This gives me a data and error. So I don't really like care about the data. Like it's pretty obvious what you want to do is like append it to a list, maybe write it to JSON, like whatever. So we're just going to care about making this loop faster. So this is how it's going to work. It's going to one by one set the offset and the limit. If there was an error, print the error, and then move on to the next one. So it's pretty intuitive, right? So we have, just for debugging purposes, get a sort of like offset equals %v and limit equals %v. I'm gonna have this here, and I'm gonna set offset and limit. So we're just having a basic thing here, and if I run go run dot, and you can see like offset 0 limit 100, and it's going to go offset 100 limit 100, etc., offset 200, 300, etc. It's going to go until we have the 1 million rows. This is going to get real inefficient. So now by this time you might have guessed what I'm gonna do, right? So like I have a rate limit of 10 requests per second in this case, and I can send actually like 10 requests per second quite literally to this API. So how would I do that in a loop? So let's think about it. Golang offers a couple things when we think about concurrency that we need to keep in mind. The two important things are goroutines, and there's one other thing called channels. And we're just gonna run through these two in a really practical way, and you just don't get like how much intuitive this is. So when you think about goroutines, it is like things that are running concurrently. So this is one goroutine, this is another goroutine, this is another one, this is another one, etc. Like you can basically have as many goroutines as your system allows you to. So you're going to have a bunch of goroutines, and each of these are going to run concurrently in parallel, sort of like in one iteration. So when you think about it, it's like, okay, I can create 10 of these goroutines, and I can just send API requests as much as I want to, and then get back the data and get them 1 million rows faster. So this is what we're going to implement. Now this is going to get real easy in Go, and it's just a lot different from the other languages. So since it's built in, it's actually a keyword, Go. That's all we actually need to do to make this concurrent. So how this is going to go? Well, I know that my iterations, like this part, is going to run concurrently. So I'm just going to have this in a function, and just like JavaScript, like when you don't give names to your function, it's an anonymous function. So this is a function that takes an I as an integer, and I is like the thing that was in my iteration. So it takes an I and it runs all of these things. So I did nothing basically here. Now, there are a couple of things that you need to do in order to make this happen. So first of all, like, okay, this Go keyword allows me to open up goroutines. Now, how do I actually know that those goroutines are finished? So that's a real problem here. I want my program to wait for these iterations to finish, because what happens is that if I run this, my computer is just gonna hang because it doesn't know what to do with the goroutines that I've made, like when is it finished, when it's not. So Golang offers a package called sync, and these are just things called wait groups, and it's pretty intuitive actually if you think about it. So it's from sync.waitGroup, and wait groups are just like things that actually wait, right? It's very literal in that it's sort of like it keeps track of your goroutines, and it's really just making sure that every goroutine at the end of the loop is finished. So thinking about this, we have a loop and we're running through every iteration. So for every iteration, I'm gonna add a new thing to my wait group. So the wait group, what it does is like it's keeping count of things. It's the accountant. It's keeping count of how many goroutines are running and which one is finished, which one isn't. So when I say wait group.add, I'm implicitly like telling it that, hey, I'm adding something to my wait group counter. So after that, in my Go function, I can say defer func and wait group done. So defer is just like a way for you to say that, hey, after this function is run this statement in the end, right? If you have a timer, you can do this. If you have, for example, in my case, it's like after this job that the iteration has is finished, decrement this wait group counter by 1. It means that this goroutine no longer exists. And at the end of my loop, when my loop is finished, I'm going to do wait group.wait. Now, what this means is that every single one of these iterations have to be finished in order for my program to finish running. And that's pretty much it. Like, that's everything that we need to do. Let's just run this, see what happens, and boom, I get a failure. So, socket, too many open files. What happened? Let's look into, this was where this part is helpful. You can see like how many requests it made, right? It made a whole bunch of requests to the API, and I can just keep scrolling up. Like, what happened here was that I didn't actually tell Go how many goroutines to run, right? I just said that, hey, just run a bunch of goroutines for me, and it was like, hey, you have a lot of like resources that you're not using, so I can just like use them and dump my goroutines into them, basically. So what happened here is that I actually have a rate limit, right? And I went way over my rate limit, and it just like, it closed down the connection. It was like, no, you cannot do this with my API. So what happens here is that I have too many goroutines open. So I need to fix this, and that's where channels come in. I love this concept. It's just very intuitive when you think about it. So like, let's jump right into it. So we know that like goroutines are these independent sort of boxes that run something concurrently. So how do we actually like communicate between these goroutines is between like channels. So channels are like pipes between these goroutines, and they sort of like allow you to sort of portal between different goroutines and communicate with them. What we're going to use right now with channels is like, we're going to create a guard that's actually not going to allow the program to open up more than 10 goroutines at once in 1 second, basically. I'm going to make a actual like channel of channel of structs. And what it's going to do is that channels actually have a cool thing in them, in that channels can have a capacity, right? There is, like, if you think about a cup, it's like, how many things can this channel hold in it? So in my case, I'm going to set a const limit, and it's going to be 10. Like, my goroutines should not go above 10 per second. So I'm gonna make a channel. This guard is a channel that has a capacity of 10. It can only hold 10 things at once in it. So if you think about channels, it's like, it has some syntax to it, but the syntax is actually pretty like easy to understand. Like, there's nothing to it. It's actually pretty visual. So if we do this, we're like, okay, so we can think about this as a sort of like an array that keeps structs, and its length is 10 and 10 only, like it's a fixed length. But it gets very much cooler than that. So what you can do is you can put a new struct to it. Now, why would you do that? So let's think about it. I am running through this iteration, and I'm adding a new goroutine to my wait group. Then I'm like, okay, I'm adding a new struct to my channel. This means that I'm adding this to my channel. So when my go function is finished, when the program is actually like in the iteration, it's finished its job, not only am I going to do wait group.done, I'm also going to take that struct that I put in off this wait group. What is this going to do? Well, basically, like, it's when this happens, since my capacity I said is going to be the limit, it's going to be 10. So it can only ever hold 10 of these structs. And if I run into like when Go wants to add the 11th goroutine, this isn't going to allow it to do that, because it's like, hey, I'm full, I cannot take more. You're not going to run here. And when it's finished, it's like, hey, I have 9 things running, so like you are allowed to come here. So like, that's the basic idea of it. And you see, like, the syntax is pretty cool actually, like how they sort of like structure how you put things in and out of channels. It's actually pretty nice. So after I'm done, I did this, so like this is gonna work. You see, it only sent 10 requests. It finished, sent another 10 requests. Finished, sent another 10 requests. And from time to time, I sort of like run into issues when it sort of like reaches the max storage limit, but it's pretty rare. Like it runs very smoothly and it sort of just adds 10 requests per second, just the way I want it. Did you see how easy that was? I know, right? Golang has been my favorite thing in the past couple of weeks just because how easy it is to kind of like just write super performant code very, very fast and very easily actually. So if this video sparked in any ways you're interested about Golang, concurrency and all of those things, be sure to hit that like and subscribe button, and also just let me know in the comments, was that really as easy as I thought it was? So let me know, and I'll talk to you soon.